Up next is averages and variation. We're going to be looking at the standard deviation. It's kind of a complicated formula that we use to do it. We'll go through two methods of finding it. But after we're done going through the process of finding it, we're going to actually be working on the calculator, because the calculator has it all dialed in. You just enter the info and it can find everything for you. Mode, median, mean, everything you need. But learning where that comes from is what we're going to work on today. So remember, mode is the most occurring. And so when you're looking at data, you want to find the one that repeats the most. And sometimes there's more than one, and that's okay. So like I have 44 twice, I have 67 twice, I think, and 87 twice. So this is considered trimodal. I list them all, 44, 67, and 87. Now, if one of these occurred one more time, like let's say there was a third 87, then 87 would beat it out. Sometimes they all occur the same amount, once or twice or whatever, and then we can also have a situation where there's no mode. But because all three of these happen twice, then we consider it trimodal, and you just list those numbers. Now the median, remember, comes when is found by the middle number. I always put the data in order. I think it's easier to work through that way, but you don't have to. If you can count your way through to find your median middle number, that's fine. If you just kind of start by looking at the smallest, largest. Oh, did I miss one? I probably did. 72, yep, what did I miss? So 9, 12, 14, 20, 24, 34, 44. There's a second 44 here. Okay. 72, and then 87, 87. All right, and so because there are 16 pieces of data, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 in from each side. 1, 2, 3, 4, 5, 6, 7, 8. And so my two middle numbers are 44 and 45. To find the median, I do 44 plus 45, hit equals, and then divide by 2, 44.5, or if you can just figure out what's smack dab in the middle. The thing you have to make sure of is when you're adding them up, you hit equals before you do division. Otherwise, it'll only divide the 45 by 2. And then the mean is where you add up all the data and divide by the total number. When you add up the data, in this case, it's 742 divided by 16. So we get 46.375 for the mean. And then the range is a new one. I don't think we've talked about that one yet. It's the max minus the min. A lot of people think the range goes as the list from lowest to highest. The range is actually in stats a number, the max minus the min. So it's 87 minus 9, or 87 minus 9, which is what, 78. So I have a range of 78. Okay, so that's just kind of a review of mode, median, mean, and then our new term range, max minus the min, single value. Difference between the largest and the smallest. And then we've got some symbols that we've seen before. Data values, X is each individual. Sometimes they'll put a little X1, X2, X3. Sample and population have the same symbol. When you have the number of data, if it's a sample, it's a lowercase n. If it's a population, sample, remember, is a subset of a population. So it's a sample is used to represent a population if the population is too big. A population is the entire complete possible, all possible values that could make up that data is the population. So if you're talking about, like a small set of data, a small situation, you can use the population. But if you're talking about the population of the United States, you would do sample data to represent that. And then X bar is a little X with a bar over the top, and mu, those represent the mean. Our new ones are standard deviation that we're going to be working with today, and variance, and then a coefficient of variation. Okay, so the standard deviation is just how it's like the average distance each value is from the mean. So it gives like the average distance from the average value each data is. So if your data is really widespread, you're going to have a bigger standard deviation. If your data is real close-knit, you're going to have a smaller standard deviation. This just goes and sort of defines everything. But we're going to go and work through the formulas. And so variance is what you get when you are trying to find your standard deviation. It's the squared version. That's what you'd end up with. And then to get the actual standard deviation after you evaluate it, you take the square root of your variance to find your standard deviation. And so if it's sample data, we do n minus 1 in the denominator. If it's population, we do the capital N. And then our what is this called again? I can't even think of what it's the name of it. Coefficient of variance or variation. There's that little formula: standard deviation divided by the mean times 100, and that's just like puts that standard deviation into a percent, like the percentage of the mean that's represented by the standard deviation. And again, the bigger the standard deviation is, the bigger this percentage is going to be, and that represents a real wide set data. The smaller this percentage is, the smaller the standard deviation is, the smaller the percentage is going to be, and that's going to represent a more close-knit data. But let's go ahead and run through the process. So we need to find all the following things for this. It's a population, so when I talk about mean, I use the mu, and the population of this data ends up being 75. The range of this data is biggest minus smallest, so 95 minus 55, or 40. And the mean, I just added everything up and divided by 5. My n here, population size is 5 pieces of data. Now, to fill in these pieces, I'm going to be using this information so that I can use this formula to find my standard deviation. And so this is just my data minus the mean, so this would be 55 minus 75, or negative 20. And I have that again, so I don't need to write that again, negative 20. 75 minus 75 would be 0. Again, the mean, 75, x is my data value. And then 95 minus 75 is 20, and I have that again, 20. So these are all of my data minus mean values, and then I have to square those. So this is negative 20 squared, negative 20 squared, 0 squared, 20 squared, and 20 squared. So those are all 400, 0, and then the last two are 400 as well, 20 times 20. This sigma notation, remember, means sum, so that means I add these all up. If I add negative 20 plus negative 20 plus 0 plus 20 plus 20, I get 0. But if I add these, 400 plus 400 plus 0 plus 400 plus 400, I get 1,600. And this is the value that I'm going to be using in my formula. I take that sum of those squares, and then I'm going to divide it by the sample size. So my variance, I'll abbreviate VAR, my variance is 1,600 divided by 5, or 320. And then my standard deviation for my population, it's lowercase sigma, it's kind of this sort of sideways looking p, and that is the 320, the square root of the variance, so 320, the square root of that, and that gives me roughly, in this case, 17.8885, whatever. I mean, you don't have to go that many decimal places. Maybe 17.9 would be fine for your approximate. And then the coefficient of variation needs you to use the standard deviation, and again, that's that formula. If I'm a population, I do the standard deviation divided by the mean times 100. So in this case, I'm going to do 17.8885 divided by 75 times 100. Plug that in, and it's just plug it in your calculator kind of thing. and I get a coefficient of variation equal to 23.9-ish%. The directions say, or up here, usually they say rounded to the nearest 1/10 of a percent. So that's how I get the 23.9%. We can run through that same process, but the next one set of data is going to be using a sample and not the population. And so the sample, it means I use that different formula when I'm going through. If it's a sample data, I do the formula is n-1, so I still need my sample size, but I'll use n-1 when I'm going through that. So these are my x values, and that's 3, 9, 10, 5, and 7. I need to find, for my sample, I need to find the mean, the range, the variance, the coefficient of variation, and the standard deviation. So those are all the things that I want to find. This first is x minus x bar, which means I have to find my mean, and my mean is 3 plus 9 plus 10 plus 5 plus 7, and divide by 5. So that's, I get 6.8 for that. If you need to pause the video and find it, it's just 3 plus 9 plus 10 plus 5 plus 7, hit equals, divide by 5, total number there. The range is the largest minus the smallest, so in this case 10 minus 3. So 10 minus 3 is 7. And then I do, I need to go through those calculations to figure out my standard deviation, my variance and my standard deviation. And so I need to know my sample size is 5, so when I plug it in my formula, I'm going to do 5 minus 1. But I got 6.8, so again, this value is 3 minus 6.8, that's negative 3.8. 9 minus 6.8, that's 2.2. 10 minus 6.8 is 3.2. 5 minus 6.8 is negative 1.8. And 7 minus 6.8 is 0.2. And the sum of all those, I get 0. That's what that bottom one is. That just means I add those all up. And then when I square those values, x minus x bar squared, I'll get 14.44. So that's negative 3.8 squared. 4.87, oops, sorry, 4.84, 10.24, 3.24, and 0.04. And again, I'm just negative 3.8 squared. Put that in parentheses when you square it, otherwise it won't take the square the negative. The whole goal here is to make sure that you have positive values. Notice how if I add together these, and I'd end up with 0, and I wouldn't be able to find the average distance away because there's that negative, so we square it and find the variance first. So when I add all those up, I get 32.8 as that sum, and so my variance is 32.8 divided by 4, and that gives me 8.2, and then my standard deviation is the square root of 8.2, and that gives me 2.864 as my final value for my standard deviation. Then my coefficient of variation is my standard deviation divided by the mean, and then I multiply that by 100, and so I'll get a coefficient of variation here of 42.1%, which means, again, that's a higher percentage. That means the data is further away from the center, or I have a bigger range going on there. All right, so that's another formula that we use. There is yet another computational formula that sometimes people think is easier to use to find your standard deviation or your variance and your standard deviation. And so we're going to do that one as well with our final set of data. That allows us to not, we don't have to do that whole different squared kind of thing. So what the standard deviation is, the sum of all the squared values minus the original sum squared divided by n, the sample size, and then divide by n-1 if it's a sample, or capital N if it's a population. So again, I just have a small population here, so I'm going to be using n equal to 5. And so what I do is I take my values of x first, which is 8 10, 4, 6, and 8, and I add those up. My sum in the bottom is 8 plus 10 plus 4 plus 6 plus 8, that's 36. And then my x squareds would be 8 squared, 10 squared, 4 squared, 6 squared, and then 8 squared again. I add those up, and I get 280. Okay, so I need to find the mean. In this case, again, it's a population, so my mean is 36 divided by 5, which gives me 7.2. I need to find the range. The range is the biggest minus the smallest, so that's 10 minus 4, or 6. And then I need my variance, and my variance is what I'm going to be using this formula for here. So it is the sum of all the squared values, 280, minus the sum squared, so 36 squared divided by n, which is 5, all over n, which is 5 again. So it's a quicker computation, I think, than the other one. And so when I do all that, I get a standard deviation, or a variance here of 4.16. That's my standard deviation squared. And so my standard deviation is the square root of that, which is 2.0396. And then again, I can do my coefficient of variation by taking that standard deviation, dividing it by the mean, and then multiplying by 100, and I get a percent difference. And so for that one, I get 28.3% when I do that calculation rounded to the nearest tenth. So what I'd like you to do is, in your homework packet, do a few problems from section 3.2a, I believe, and then we'll work on the calculator values when you're in class tomorrow. So 3.2a gives us, 3.2a, general concepts, the variation and standard deviation. It gives you a few things to calculate. I think there's 2 of them for you to work on. And then you can come with questions tomorrow. I hope you're feeling better, and we'll see you soon.